Have you ever found yourself frustrated by complex code that just doesn't seem to work? If you've ever wondered why certain features in C++ don't behave as expected, you're in the right place. Today, we're diving into the intricacies of SFINAE and if constexpr in C++. I totally get it. Trying to simplify your code while maintaining its functionality can feel like a never-ending battle. You're not alone in this struggle. Many developers face similar challenges when working with template metaprogramming. Let's take a look at a specific question from a user. Why is SFINAE with if constexpr not allowed? They shared their frustration about the amount of typing required to check for the presence of a member function in a type. Sound familiar? Let's explore this together. So what's happening here? The detection idiom you've shared is a common way to check for the existence of a member function in a type. However, the alternative approach you suggested using std void t doesn't work as expected. Let's break down why that is. And stick around. By the end of this video, you'll not only understand the limitations of if constexpr with SFINAE, but also gain insights into the trade-offs involved. To understand why using if constexpr with std void t is not allowed, we first need to look at the purpose of SFINAE, which stands for Substitution Failure is Not an Error. This principle allows template instantiation to fail gracefully without causing a compilation error. When the user tries to use a std void t in the if constexpr statement, it changes the context of SFINAE. The if constexpr statement evaluates at compile time, and if the expression is invalid, it leads to a hard error instead of a graceful failure. If this were allowed, it would introduce ambiguity in template specialization. The compiler would struggle to determine which overload to use, leading to potential conflicts and unexpected behavior in template metaprogramming. In summary, while the user may find the syntax cumbersome, the restrictions are in place to maintain clarity and predictability in template programming. This ensures that developers can rely on SFINAE to handle type detection without introducing complexity. Fun fact, did you know that the C++ programming language was originally designed in 1979? It has evolved significantly since then, but some of these complexities have remained. Now let's look at the answers provided by other users. An alternative approach suggested by a user is to use std experimental is detected to simplify the code. Instead of the longer detection idiom, you can define a has_t template that checks for the presence of foo in a type. Then you can use if constexpr with isDetectedV to determine if var has the foo method and call it if it does. Here's a takeaway. Embrace the complexity of template metaprogramming. It may seem daunting, but mastering it can lead to powerful and efficient code. Keep experimenting. And there you have it. Understanding SFINAE and if constexpr can be tricky, but with practice, you'll get the hang of it. If you found this video helpful, don't forget to subscribe for more insights into C++ programming.